Hi everyone, it's Orkan. Today we have a problem when we are given an array nums and we need to find all quadruplets, which means that the 4 elements, sum of which is equals to our target. Let's say that in this case our target is 0. So how are we going to solve this problem? The first thing that we do here, we are sorting our array, right? And after sorting our array, what we do? We are taking each element. So for example, first element, and we're starting from the first element. We are taking the first element, and for the first element we are considering the next element, right? Next element. And for the rest of the array, we are applying two-pointer approach. So for example, in this case, we are taking -2 and the -1, and on the rest of the array, we are looking for the two more values that in sum with the -2 and the -1 gives us 0, right? Because our target is equals to 0. So for example, in this case, -2, so in this case, -1 and the -2, right? So our left pointer points here to the 0 and our right pointer points to the 2. So is -2 plus -1 plus 0 plus 2, is it equal to 0 to our target? No, it's not equal. It's actually less than 0, so which means that we need to increase that, right? So we need to move our left pointer here. So we are moving our left pointer, now our left pointer here. So our left pointer here and the right pointer still the same. So we are adding, so in this case, again, these are duplicates, 0 and 0. It doesn't give us our target. Again, it's less than our target, and we are again moving it's less than our target, so we are moving our left pointer again. So again, -2 plus -1 plus 2 plus 1 plus 2. Does that gives us our target? Yeah, it gives us our target, and we are adding that to our result. So that's our first quadruplet. Now let's say that we have considered, right, for the -2 we took the -1, and the next one is that what we are going to do, we are going to take the 0, and we are going to again perform, and we are going to apply the two-pointer algorithm on the rest of the array, right? So -2, 0 and 0, 1, 2, and after, let's say that we have finalized all options, right? So for the -2, and the next element that we are taking here is -1. So we are taking -1, and again we are applying the same logic as we did in the for the first element, right? So we are taking the next element, and for the rest of the array, so we are taking one by one each element, and on the rest of the array we are applying two-pointer approach. So for example, in this case, -1 and the 0, and the rest of the array is 0, 1, 2, we're applying two-pointer approach. So what we do here, our left pointer again points to 0, and our right pointer points to 2. -1 plus 2 plus 0 plus 0 plus 2 gives us what? Gives us 1, so which means that it's more than our target. So we are moving our right pointer. So we are moving our right pointer again. Now we are taking -1 plus 0 plus 0 plus 1. Does that equals to our target? Yes, it exactly equals to our target, and we are taking that as another quadruplet. So as a solution, the first thing that we do is we are creating a result that where we are adding our quadruplets. If the length of our nums, if the length of our array is less than 4, then in that case we cannot form quadruplets anyway. We are returning an empty result. If not, then we are sorting our array. We are taking the length of our nums that we are going to use here, and we have two for loops. The first for loop, that the first element that we are considering, right? And the second for loop, that the all consecutive element after the first element that we are considering. For example, for the -2, right? So for example, for -2 we took the -1, 0, and the all consecutive elements. So this is for the first element, this is for the second element, and also for each element we are checking that if there is a duplicate, then we need to skip those duplicates. We just skipping those duplicates, and we are continuing. And after taking the first element and second element, what we do is we are defining our left pointer and right pointer. Left pointer in this case is j plus 1, and the right pointer is the last element, right? So that's our right pointer. And while our left is less than right, so what we do is we are taking at each step total, which is I, our first element, our second element, and whatever we have at the left pointer and whatever we have at the right pointer. So we are taking the total, And then now we are checking our total. If total is equals to our target, then in that case we are adding that quadruplet, exactly the same quadruplet, we are adding that to our result. And after that we need to also skip the duplicates here, right? So we are, while our left again less than our right, so we are checking that if the elements left and the element that is next to left, so which means that the two adjacent elements, if they are equal, then in that case we are just skipping that, so we are moving our left pointer. The same we are doing for the right, if the two adjacent elements are the same, so which means that there are duplicates and we don't want to add duplicates to our quadruplet, so we are moving our right pointer. And once we exit these two while loops and we added that to our result, now we are moving our left pointer and right pointer, and we are searching for another set of the quadruplet. And if our total is less than our target, right, as we have seen in our example, we are moving our left pointer. And if the total is more than, then which means that we need to decrease our total, so we are moving our right pointer. And at the end, we are returning our result. So what's the time and space complexity of this solution? The time complexity of this solution is n squared, so n cube, because in this case what we do is it's not n squared, but it's an n cube, because we have two for loops, right? So we are taking each element, and for each element we are taking the next element, and for the rest of the array we are applying two-pointer approach. So which means that the n multiplied by n again, it would gives us n cube. And for the space complexity is we are not using any additional space. We are using result, which is part of the result, which is part of the result that we are returning. So we are not using any additional space here. So our space complexity is of 1. I also have identical solution in Java. I will include that in the description. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.